Welcome. And as I said, thank you so much for joining our webinar, which is on the easy and accurate RF compliance with our tool IXUS. Now, I'm looking through the audience list at the moment here, and I see some familiar names, but also quite a lot of people that I don't recognize. And that tells me that you probably have no idea what IXUS is. But that's good. So I'm going to give a bit of a presentation for a few minutes just to tell you how we fit into this world of RF safety compliance. And then I'd like to show you how our tool works, not just tell you. I want to illustrate it in real life with a bit of a demo, and then hand over to my good friend Drew Thatcher, who's currently sitting in Seattle, to tell you a bit about some of the case studies he's been doing and using IXUS for. Okay, so as I said, some of the things might go fast. But in that case, we're going to record this as well. It's currently being recorded, and we'll make the video available on our YouTube channel. And I'll share a link with you so that you can access that afterwards. Okay. If you have questions, paste it in the chat. And my other colleague, Johan Nell, who's also part of the IXUS team, he will try and answer it as we go on. Okay, so let's get going. So firstly, this is the agenda. I want to tell you guys a bit about who we are, how we fit into this field, and then emphasize a little bit the IXUS philosophy. Our philosophy is on simplicity. So we want to present you guys with a simple workflow that's efficient and also, above anything else, accurate, so that when you do site analysis, RF safety analysis, you know that you can be confident your results are correct. And then I would like to show you how this easy workflow works. Bit of 3D modeling, generating results, and how you can manage it. And this I'll try and keep to 10 minutes to just emphasize the fact that that it really is built with simplicity in mind, and also something that you can be confident anybody in your firm can do quite easily and consistently. Okay, and then I'll give over to Drew, which will tell us a bit about the case studies he's been doing in the USA, and then finish off. Okay, so first off, what is IXUS? Who is IXUS? Who are we, and what are we trying to sell you? So firstly, IXUS is part of a pretty big technology investment firm called Alphawave, and we've got quite diverse bunch of companies, sub-companies, or products within this big investment firm. It ranges from field apps to machine learning, electronics, and so on. But the core of this company was actually established in the 1990s. And all of the original companies that formed part of Alphawave, is core focus was on electromagnetics, either with products, with services, or with software. So some of these products you might have heard of already. One is FieldSense, which is it's a market leader in personal RF monitoring solutions. So it's a little unit that looks like this. Tower climbers can clip it onto them, and when they go up towers and work in an environment where there's radiating sources, they're confident that they are being protected. It's a wonderful unit, works over a wide range of frequencies, and it's also being distributed in the USA, but also worldwide. Then we've got part of our global company is Alphawave Mobile Network Services, who was established in 2005. Now, this is a service company that specializes in RF awareness training, in 3D modeling and simulation of base stations, towers, and so on. All of it is done using IXUS. So this also emphasizes a key point to our product, is that for over, almost 15 years, we've been really influenced. We've designed our tool with the help of companies that really is specializing in this arena. And then, of course, IXUS. So IXUS was the first commercial version of IXUS was already released in 2009, and it was branched off a market-leading commercial computational electromagnetic software tool called FECO. And FECO is now owned by a fairly large firm, in a global firm called Altair, which is also based in the States. Yeah, so since 2009, we've refined our process of delivering this industry an easy to use and accurate solution that is completely focused on RF safety assessment. In the last 2 years also, we've spent quite a lot of time and money and research efforts to refine our product offering, with advances in industry that we noted, specifically around 5G development. I will tell you a little bit later about our antenna modeling process, but that is something, a key point we've really been focusing on is 5G antenna modeling. And also the support for features that is used by other countries, specifically the US. Things like support for imperial units, the way in which results are visualized, and so on. Okay, so we operate in quite a worldwide. A large part of our client base is in Africa, as we originated there originally about 15 years ago. But since then, we've also entered for a very long time. We've been the leader in Australia, in New Zealand, in Europe, and also in Canada. And we've got some excellent collaboration projects underway, such as, for example, with Andrew Thatcher, that you'll hear about from now, in the US over here. And we've got a couple of other users as well. And our clients are far-reaching. We have in our user base people from manufacturers like Ericsson and Huawei, and also from consulting firms. We've got government institutions like the ICD in Canada. We've got operators, for example, like Bouygues Telecom in France. So we do cater for a variety of these markets, and each of these markets we spend considerable effort on getting to know fairly well, because that's important from a support perspective, but also because we take into consideration what our clients want and need in IXUS, and that forms part of our long-term vision and roadmap for the product that we provide you with. Okay, so the IXUS suite, as I mentioned in my first slide, is based on simplicity and accuracy, and it should be something that anybody can use, and that your modeling is done with ease. So to do that, we deliver you with two core components that makes IXUS. The first component is a web-based application. We call that the IXUS Manager, and it's basically a website that you log in, or a web application that you log into. All the users of the company that is taking responsibility for the RF safety assessments. And in the IXUS Manager, you can manage all of your sites that you need to analyze. And the IXUS Manager also supports a couple of very cool features as well. One is automatic report generation. So I will show you that basically with a couple of clicks of buttons, you can apply a fixed report template or some report template that you set up to the results that you pull in to the manager sites, and then you can generate reports very, very quickly and very consistently. You can also pull in other types of data, like, for example, data from an SRM measurement device directly into your base station sites. And it's just a one-stop shop to manage all the information that is associated with your RF safety assessment for a particular site. Then where the actual magic happens in terms of RF calculations, that is done in the IXUS modeler, which is a desktop application. It's a Windows-based desktop CAD application, to be exact. And in that tool, you will generate the buildings, you will draw your shapes and sizes, you will import things like blueprints, for example, Google Maps, things like that to model your site. These are the IXUS modelers, the people drawing the site. And then also you position and apply your antennas at particular points, like for example, these points over there. And then you generate the results. So all of that information goes to an accurate EM field calculator called the field assessment calculator that is also run as part of the IXUS modeler, and the results are generated in the form of plumes. But I will show you also a bit more on the type of results that's generated in IXUS, in the IXUS modeler. And then pictures are saved here in this environment, and it's synchronized back into our IXUS manager, where, as I said, with a few clicks, you can generate a report. Okay, so just to recap, getting a site survey done is a three-step process. Step one is you gather your information. That includes your as-built documents, drawings, photos, even other CAD files that might exist, like DXF files and so on. You upload these to your IXUS manager. You can also incorporate measurement data directly from your devices like the NADA SRM. Step two is you then extract this data in your IXUS modeler, and you draw your site with your buildings and so on. You place your antennas, and you generate your pictures, and also maybe, for example, points of interest like field points or slice data and so on. And then step three is that information is all synchronized back to the IXUS manager, with which you then can generate a report based on a preloaded report template. Okay, so these report templates are fairly easy to set up. It's based on Microsoft Word. And you can activate a feature in Microsoft Word which exposes content controls. Now, we've set up quite a few content controls that you can use to automatically link information to the report, like, for example, the site names, the locations, the details, and so on. But in this report, you can very easily then get access to the equipment that's installed on site, all the pictures that you've generated in your modeler, and so on. So it's a fast way to generate consistent reports, something that might be very useful for near or EME reporting. And it is very fast, as I will show a bit later. So something that I think sets IXUS apart from other, really set IXUS apart in the industry and makes us a market leader in this field is the length to which we go to ensure that our antenna models is comprehensive. We've got over 4,000 antenna models available on what we call the IXUS portal. And we also make sure that it's accurate, that it resembles the information that we get from antenna manufacturers, and that is in the form of verified data sheets, pattern information, and so on. And we really do use a combination of methods, some of which is based on full wave techniques, to get the most accurate representation for what that antenna will do when used for RF safety compliance studies. And as I said, we've also gone to quite great lengths to ensure that our 5G modeling antenna models are really industry leading and really representative of what this new technology that is taking the world by storm, what it really is doing in terms of RF safety. In terms of verification, we issue accredited verification reports that we either compile using independent external experts that compares our tool to full wave methods, verified full wave methods. We've got our own internal verification reports that we can make available for each antenna upon request. And we also spend time talking to our clients and making sure that they are happy with the products that we provide them. Okay, so that was a snapshot about IXUS, but in order to really get the gist of it, I would really like to show you a quick demo about, should take about 10 minutes, and then I'll hand over to Drew. Okay, so I am going to start off with the IXUS modeler environment. So remember, this is a CAD-based application that is installed on your machine. So here I've already got a site loaded. It looks empty in the beginning. But typically what one would start off with is you would start off with a blueprint. Now, this is just a Google Maps image of a region over here. And we've got some buildings over here. So if we want to model something, it's very easy. Anybody that's got some experience with CAD-based tools, even something like Google SketchUp, will be able to draw something over here. So let's look. Let's say we want to draw this building. Then you can very easily, there's a couple of ways in which you can do it. I'm just going to use one of the methods, create a polygon over there, click on a few points. I'm doing it quite quickly now. So you can obviously zoom in more and get more accuracy out of it. But there's my shape. It's still flat though. And IXUS is a 3D type of environment. So we can extrude that now to a particular height. Let's say 15 meters. Now at this point, I should apologize. I'm going to work in meters because I'm from South Africa, but it is easy. You can just go to edit, preferences, and you can change that if you would rather work in feet and inches and so on. Okay, but I will stick to meters. Okay, so now we have a building over here, and this is a very simple shape that I show you. What I'm going to do is I'm just going to show the complexity, really the type of complexity that you can get with IXUS. Now, as you can see, there's different building. This is one example of a more comprehensive building drawing. But apart from that, one can also include things like, for example, here is a pole structure, or we have primitives that you can use to easily set up, for example, a tower. Look at this. Here we have a tower, and we are extending the type of primitives that we have available in IXUS on quite regularly. So yeah, so as I said, you can add these predefined architectural components as well. Okay, now this is my site. Let's say I want to enhance it now, and I want to place an additional antenna and radiate some energy and see how that influences my assessment. So let's take, for example, this building that I have over here. So okay, well, maybe I missed that little container that was sitting there on the corner. Okay, and somebody on this building now says that they want to place an antenna. Antenna. Let's take as an example the Nokia AWEUC antenna. Before I can actually get that antenna, I need to go pull it from a database. So as I mentioned, we have a fairly, sorry, I'm just going to find the right screen over here. We have a fairly comprehensive database of antennas on our what we call the IXUS portal. So if you've got a valid maintenance and support license, you can go to portal.ixusapp.com and you can log in, and you have different functionality on the portal, but the most important one that I want to show you now is our antenna database. So here we have over 4,100 antennas at the moment from all sorts of manufacturers and different type of models, different types of antennas, from panel antennas, omni antennas, reflectors, dipole arrays, everything, 5G antennas covering different frequency bands and so on. So here on this, you can easily search for the one that you need. I was looking for the Nokia AWEUC, so here I have it. I see some details about it. Its height, for example, operational frequency band, its gain, vertical and horizontal beam widths, and also this particular unit might have other things, like, for example, a configuration or additional notes and so on. But more importantly, I can download this antenna. After I've downloaded it, I can import it into my IXUS modular environment. And then when I have it in the environment, I can go place it. So let's say I've done that. Just to make things a bit more clear, I'm going to just focus on this little section at the moment. So let's say I want to put my antenna somewhere on this little elevator shaft. Go look for it over there. Now I have it. Okay, I see it's only got one particular frequency band. If it's a multi-band antenna, I can also then select which which frequency bands I want to apply by adding those individual ones, and then I can set the power of each frequency band. And I'm not going to go into the details of it, but we've got some advanced functionality as well. There's things like feed system losses that you can add. You can add scattering reflection. We've got some stuff on uncertainty calculations that you can add as well. But just for the sake of this demo, I'm going to say, let's ignore the losses. Okay, so now I've got my little antenna. It's that green unit sitting over there. If I zoom in, you could see it. So that green is now the radome. Well, it'll solidify when I click. Okay, and I want to click it. Let's say the height is, let's say somebody mounted it that didn't really understand where to put an antenna, and mounted it at 15.5 meters there on this little edge. And you can adjust things as well, like, for example, the tilts and so on. So let's tilt it there. Let's call it the AWEC, and there it is sitting. So I've got its label over there, and it's saved. Okay. What I'm going to do is I'm just going to disable the other antenna so that I just focus on this one. But it is important to note that we do allow multiple antennas to be simulated in the same model. Okay, so the question is, what is this one looking? So I can calculate its exclusion zone, or what we refer to as plumes. Now, this is, for some of you, this might be new. This is a three-dimensional view of how this antenna is contributing towards a particular safety standard. So the yellow is where the public safety zone is exceeded, and the red is where the occupational zone is exceeded. Okay, so the question then is, let's say I've got a guy here, is 1.75 meters tall, just under 6 foot. We typically call this guy Jeff. So we want to know, where can Jeff walk around on this surface and make sure that his body is not exposed to any of these regions. So there's different ways in IXUS to do it, but one of the very useful methods is to do a lobe imprint. So we want to imprint this lobe, or at least the points where Jeff's head or body or so on will touch that zone. And you can decide, so you can apply a lobe imprint, and you can say, okay, let's make it 2 meters. So let's make it Jeff plus maybe somebody on Jeff's shoulders. So what I can say now is, if Jeff walks, let me just say, if he walks into this region, he's going to be overexposed. So you need to mitigate that. So an easy way in IXUS to do this, for example, this particular example, let's see what happens if I move this antenna up a little bit. I can now set it a little bit higher. There. I can simulate again. And you can also adjust the accuracy to which you do, or the speed at which you do this. And that's just associated with the display of this three-dimensional plume. And now if I do this lobe imprint again, you will see that the problem went away. This is just one example of how to do this. Okay, if you couldn't move it, then maybe you would like to put in some form of a sign. And these signs you can also manage very easily for any of your sites using the IXUS Manager. Okay, but we've moved it up. We've got a three-dimensional plume, but that might not be what your clients to which you have to issue the report wants to see. So we can also visualize this field distribution on a planar structure. And to do that, you can use this environmental slice, which is basically calculating the field on a flat surface. Okay, so I'm going to put something like this. Let's say we put it there, okay? And we're going to calculate the field then on that plane at a particular height, in this case, 1.5 meters. It can be calculated, it can be calculated on that plane using what we call point spatial, so only at the individual points, or you can apply spatial averaging. And what spatial averaging will then do is calculate the fields under that slice within this particular range offset at spacings that you specify. So you can specify 0.1 spacing spatial averaging setting. So just an advanced feature that I'm not going to touch on now or expand on now. Drew will say something about it in his case studies. But now let's just keep it at point spatial. And something additional that I want to do is I want to say, what is the maximum of the field in this plane? So I can say, okay, I want the maximum. All right. And there it is. So if I hide my plumes or these exclusion zones, there I've got my field. I can also place that a bit there. There we go. That's the field on that particular plane, and that's its maximum value reported in percentage. You can also set it to volt per meter or so on. But this is a continuous visualization of the field. Now, something that you are, for our US-based clients might be more accustomed to is to group these results into various, let's say, buckets, discrete buckets, as you may call it. So if I change it like that, now I can see it here. Let me just hide. Let's place a legend for you here. There you go. So now I've got my field sampled on this plane with these buckets set. Something that I want to point out, it's currently set to ICNIRP, and I realized when I said USA, you guys might be using something else. So that's very easily changeable in IXUS. You can change the safety standard to anything. Here I was just experimenting with the new IXUS 2020 local and whole body average values, but you can change it to FCC, safety code 6, Serbian, whatever standard. In fact, this is a customizable XML file that you can edit and upload to the IXUS Manager and pull it into the IXUS modeler. Okay. So I've shown you 3D ways to visualize the results, the 2D way in which to visualize the results, and then we've also got, if you just want to point a point, right? So I've got a little point tool, a field point probe, and I can put my probe anywhere. There's a value. I can set it to a particular point. Let's say I want to sample it at 2 meters, or more popular, you can sample the field within a particular range. So a start height, in this case 0 meters, relative to this surface. You can snap it to anything else also. There are 0 meters to 2 meters, and in that region, you can then select what you want to see. Do you want to see the maximum? So it will return the maximum of the field in that region, or the spatial averaging. You can say, okay, in that region, sample the field at this sampling interval and report for me the average value. So this is now in terms of percentage, but I can also report in terms of a volt per meter over here. And then what we can do is we can take a picture of my results. There you go. I've got a nice picture. It's a live type of picture, which you can adjust then according to what your needs are. And then when you're done, you can save all of this back to the IXUS manager. So let's do that. Type something more comprehensive there. These are pictures that's already been set up previously. I deactivated those antennas before I did the simulation. Otherwise, there would have been results here as well. Okay, so everything is saved back. And now we're running through the upload. So this upload process, it requires an internet connection between your modeler and the IXUS manager. Now, that is something that we also try and simplify for our users by offering a cloud-hosted IXUS manager solution. So for a reduced cost, we manage your IXUS manager, We make sure that it lives without any issues in the cloud using cloud-based AWS services, which we back up, we make it secure, we can then provide very easy support. But if you would like it on premise, we can do that as well. Okay, so in the IXUS manager, I'm just going to go through this part very quickly. I'm not going to show you all the components associated with it. You basically log in. If there's a new update to the modeler, you can grab it here. You see all of your sites. So for this particular one, let me just find it. I've got it here. I can open it. This is now this particular site. You have various settings. You can set its name, its longitude, latitude, which you then provides a little Google Maps link, its details, and so on. Measurement results, if there is. If I've saved back field point data, it will also be displayed over here. Now, the position of it and the value. It gives you details about what's the antennas that's on this particular site. So here I can see I've only got the Nokia AWEC active. The other ones I've deactivated. And if I hover over it, I can then see where it's positioned in terms of height, azimuth, offsets. Doesn't have a mechanical tilt, which frequency bands have been applied, as well as the power settings. And then, as I said, something that's important is the results are now saved back here. Okay. So what you can then do is you can just click on IXUS report if you want to generate the report, and click on the gear icon. You can apply any one of your interesting templates that you've set up. For now, I'm just going to use a standard template. Click next. You can add some default comments or type some signage comments. You can choose which pictures to include and which to exclude. Let's say I don't really care about the tower one at the moment, but the other ones I would like. Click on next. If you've got some actual pictures like site pictures or so on, you can add them here as well. You click on next and it's done. We've generated the report within a couple of seconds. And now this report, if it's finished, I want to show you an example of what it looks like. It's finished. And in the interest of time, I've already downloaded it and opened it here. Now, it is something you can customize and tweak a little bit further, but it's got all the important things. It's got your site number, your internal number, and now this information is pulled from the site in the IXUS manager. It's got a bit of a preamble over there. It's got specifications about what these plumes mean, and all the pictures that I've generated using my IXUS modeler. So yeah, so these are the ones that I've added. I've got my field point information that I've also got, that I've also requested in the modeler. Some information about my environmental slices, particularly where the maximum was. This site calculation scheme. So it specifies whether you used point spatial calculation or spatial averaging. Information about my antennas, their heights on the site, azimuth offsets, frequency of operation, the power applied to each of the ports, and so on. And yeah, this is, but as I said, it's a very basic template example. You can set up more comprehensive things to make it look to suit your needs. Okay, before I give over to Drew, I just want to mention this, that please visit our website, ixusapp.com. If you have any questions, then I would appreciate it if you can send us an email and we'll get back to you as quickly as possible. I will record this, and if you guys want to watch it afterwards again, it's on TinyCC, the IXUS YouTube. This is a link to our YouTube channel. And very important, if the best way in which to get to know our tool is to try it yourselves. So we offer you a fully featured trial. We'll set it up on AWS for you. We will provide you with assistance to get going. We'll generate some antenna models. If you can't find it in our portal, which I highly doubt, there's over, as I said, over 4,000 different ones, and we get some free training to get going. Okay, in terms of costing, don't worry about it at the moment. We'll find something that works for everyone. And if you have an existing tool, transitioning is rather straightforward. We'll assist with the porting process. We've got a team of very, very clever developers that can help with that. So please get in touch with us on this.
I've been using IXUS now for probably about 1.5 years. I first contacted IXUS back in 2019 simply because 5G was something that really couldn't be done with the software that was currently available in the United States. So I searched out a group and I found these people out of South Africa that did amazing stuff. And so I've been collaborating with them ever since. It's great stuff. Everything that I'm talking about here is stuff that I've either done and even in the past few weeks, or there was one site, the first one I'm going to share is one that this is a condo here that you can see in a picture in a very dense urban environment. And they have a rooftop access with picnic benches, etc. And they are right next to the antennas. And actually, I'm sure you will think that that's pretty crazy. So the condo owners hired me to come basically do a validation and verification of the operators that were there, even though those same operators usually hire me for other sites, but there you have it. So the nice thing about this, look at the details of the model of this rooftop. Now, of course, this is something that took more than a few minutes to create, but you can get incredibly detailed modeling for this. And the thing that I like about this is that oftentimes when I create my rooftop electromagnetic exposure reports, etc., those are used, let's say in a university setting or what have you. They have that report that someone who's going on the roof can then review and see in great detail exactly what's going on so they know what to expect when they go up there. So I find it incredibly useful. Next slide. So here is that close-up image, and if we click 2 more buttons, you're going to see some pictures that go along with this. So here you'll see this rooftop environment, and here you have the shroud that is behind the antennas. And standing here, it looks like it's possible that those antennas are right at head height, but the truth is the bottom of the antennas is about a little more than 7 feet in the air, so it's not quite as bad as it looks. But still, there's a picnic or a table here, and there's a bench back here just out of the picture, and you can see this area. And so, of course, this is the area that I did a survey on, because everything else is essentially off limits to members of the public. So they wanted me to focus on this. One of the great features, as Danie had spoke of, was the spatial averaging. And anybody who does surveys and measurements knows that generally speaking, a peak spatial number with the higher limit is harder to exceed limits for that, but yet a spatially averaged value can be generally more conservative. So I'm more interested in doing both And in this case, I've done the spatially average because that's what usually runs into problems. And you can see here in the green, that's less than 20% of a public limit. The blue here is anywhere from 20 to 100% of the limit, but yet not over the limit. And then we'll go into some other details of this. Next slide. You can see an overhead here, and here's an interesting part. I hope everyone can see my mouse as I scroll over that, or no, because I'm not sharing, you can't. I wanted to show this little area here to the left of the where the field is, where the bench and everything, and it's just outside of the area. Take your mouse to the left, Danie. That probably will help. There you go, the yellow area to the left. And that's just outside of the area that they have the fencing for the members of the public. But this is incredibly detailed, and I'll show you very accurate as well. Next slide. Again, just as another view, and you can see that the view you're looking at here is an environmental slice of the entire building. And when you do a spatially averaged over an area that is thousands of square feet, computationally, that's pretty intensive. I think they're working on improving the speed of that, but that'll take a couple minutes to get done. But it's amazing how detailed, and we'll show, you can see in the highlight where the yellow areas are, they already had existing fencing that's surrounding those areas. There's one area here, which I had to contact them about, that they missed, which was an area that exceeds the public limit just beyond the fencing here. There you go, right there. So that was something that they didn't find in their previous models using a different software. Next slide. Same thing again, just talking about the spatially averaging, et cetera. A lot of great information in here. Again, when you import one of these images and then you can overlay and create what you're doing, it's very, very accurate and a great way to go. Next slide. So when I went on site, I use an MBM 550 with the suitable probe, and that's what I do my measurements from. So when I take those, I do a average of 6 that I do 0 to 6 feet and take that statistical average. The maximum locations that I found were the ones here at 82.4%. The measured value was just under 80%. And then over here, it was just under 70%. I had the measured value at 64. We calculated using IXUS at 69%. The one here that's closer to the antennas, and again, such that would be significantly less, just because on a spatially average value, your lower body is not getting as much exposure from those. But you can see how just moving the measurement point to the right or left or something like that, a small amount would significantly change what the result is. So that one probably tougher to hit exactly, but I'm very, very happy with how close yet still conservative the results were. One of the things that, at least in the United States market, is we're sending out surveys that are done after every single installation because of a few basically failures to predict where high points were on buildings, et cetera. IXUS has the ability to be very accurate. You can include scattering and reflection in the analysis, so you can get very, very accurate results. And I think one of the things that we'll be able to do is limit the amount of rooftop surveys that are done because of the accuracy, yet still being conservative. One of the other problems I find is that a lot of times software models will be so conservative because they'll use a cylindrical model in the closer to the antennas, and it's wildly conservative. If you've ever done surveys on sites and you've used, you know that the spatially average value close to those antennas, if they're above the height of your head, it's probably not going to exceed the public limit or the occupational limit, yet you'll find models that do that, and that's a real problem. And IXUS really overcomes that, and I'm really glad to be able to use that. Next slide. And this is just showing that we did 0 to 6 feet, taking those statistical samples, and the accuracy. Like I said, I'm very happy with how accurate these are. This is incredible precision in my mind. Next slide. So, and this is referring again to how useful this is when I prepare a report and send it into a client, especially for a rooftop environment. It needs to be very detailed so that the people who are implementing the signs and fencing or what have you can know exactly what it is they need to do. So at least for my clients, they absolutely love this kind of detail because it's about as clear as it gets. So now if someone like the radiation RF safety officer comes up to audit or something, it's very clear what has to be done. So I like it a lot. Next slide. That just shows here on the left with the image and what we've got in real time. So it's very, very easy and quick in the IXUS model to include that kind of stuff. It's not like something I have to spend a ton of time creating and tedious, and it's just very easy and quick to do. Next. And more of the same. This is on the other side of the building where no one actually has access. You can see these are yellow caution signs, which mean they potentially exceed the occupational exposure limit for the FCC. And of course, you'd want to notify everybody if that were the case. Next slide, and I think we're on to, here's another building I was asked to take a look at. And again, I was asked to take a look because a different software model showed the site failing horrendously, and that simply wasn't the case. So in this instance, you look on the right here, and this is the reverse side of this building, but you have multiple rooftop environments, and we were able to take environmental slices of all of those and show the results. So next slide, what we're going to show here is the penthouse, that highest area that does have the antennas. And here you have an access hatch, and I have several signs, the caution notice sign, and then the blue FCC general public notice. Before you go into it, it's very clear where those postings should be. And then near the antennas on the fencing, we have warning signs. These warning signs, as the notice would say, would be only if you stepped out of the railing on the other side. And I'll show you what I mean here in a second. Next slide. So by using this software, I'm able to model the environmental slice exactly inside of the fencing, the railing around this penthouse. And you can see none of the areas exceed the occupational exposure limit. You've got an area in the northwest corner where you're potentially several times above the general public exposure limit, but that's fine. We've got the notices, we can handle that. And then if we go to the next slide, you can see that the difference is if you were going to be on the outside of the railing, of course, a worker would have to be in a harness, a safety harness, what have you. But it's useful for them to know, were they to go out there, what kind of an environment they would be stepping into. And that's the kind of flexibility that's just really helpful for a site when you've got people working in and around it so they know exactly what's going on. That's the whole point of RF safety. So next slide. I've got another building, and I just did this last week, so I just threw this on here because it was pretty interesting for me. So Danie and Johan, of course, are very, very versatile in using this. I'm perhaps not as much, but I love it a lot. So I take a construction drawing, I import that in. I could have done a picture, but when I'm working very fast, it's very easy to do a construction drawing as well. I have 3 buildings, and I took 3 buildings, and then I made those at the heights for which they are, and then I ran my analysis. And you can see on the building to the bottom here, I did an environmental slice here, and it's not as easy to see, but I did an environmental slice on the other roof. And the whole reason why I was asked to do this was because I felt that these roofs were exceeding the limits and no one had identified those as a potential problem, which is a problem. So next slide, I think I've got a 3D view now of the modeling that I did. I did all of this work, I think, in under about 40 minutes. It's just a huge time saver for me to be able to do all this and do it so quickly. Danie, if you could point out, I did a slice on the vertical portion of the building to the right because we have an antenna in the corner that's only about 5 or 10 feet above this other building. So it's possible that windows or a balcony or something on this other building might have exceeded limits. So I specifically analyzed for that. So you can, the flexibility of the six software, I almost can't overstate. You can do just about anything you want in terms of analysis and do it very quickly. Next. So this would be the example more of a final report. It did turn out for this that those 3 buildings are owned by the same landlord. I reached out to them and they're comfortable with limiting exposure to the other buildings. So we didn't have to move the antennas, increase the heights, change the azimuths or all that stuff. We just simply had to now put barriers up on these other buildings to make sure we're compliant. And that's a win for everybody. So that's, like I said, is something I was able to do in very little time. And yet previously, this would have taken quite a bit of time, especially since one of these antennas is now more toward the 5G bands and gets things a little more complicated. Next slide. And this is just an example. For one of the carriers in the United States, I do a tremendous amount of small cell analysis. So they'll give me all of their antenna combinations for the coming year, and I'll take a look at all different combinations and power levels and heights, and we do an analysis so that before these go out into all the regions and the markets, we know if there are any problem areas before we even go out there. And there's 2 things that this analysis is easily able to do. Obviously, ground level analysis where I do a spatially average value, but another important feature, I work for a lot of utilities. So they have the light poles, the power poles, you name it, and they're very interested in workers in their boom trucks and what have you. How far away can you be from the antennas at the height of the antenna? What's my exclusion area for the occupational exposure, for the general public exposure? And this kind of analysis is obviously for just a pole, very, very easy to do, quick to do, and yet incredibly accurate. And a picture tells 1,000 words. So when I do training for RF safety for utilities or what have you, and I include images like this, they get it. It's very, very easy for them to understand where things are going. And if you're under the antennas, obviously you're safe until you get up in that field. So that's really all I wanted to share with what I'm doing. I'm probably not the biggest I'm as well versed as these guys are. So I just learned, actually, one of the things I'm going to do for a site tomorrow was Danie's example where he had antennas in multiple locations. I have that exact situation next to a school where they built the school and they put the playground on the rooftop, if you can believe it. And of course, you can imagine there's antennas next door to them and not too far away. And so the parents are worried. And so the IXUS is a perfect mechanism for doing the modeling of all these antennas that are nearby and finding out exactly what's going on for that building. So very interested to do that. And so the light bulb went off for me today. So I thank you for that, Danie.